Let's jump into the tech news for September 3, 2025.
Project Moohan XR headset leak.
Samsung is preparing to enter the high-end extended reality XR market with its rumored Project Moohan headset. Reports suggest a launch in Korea on September 29, with a steep entry price near $2,999. The device is expected to combine ultra-high resolution displays with spatial computing features, positioning it as a rival to Apple's Vision Pro and Meta's Quest Pro line. Early leaks hint at advanced hand tracking, powerful processors, and a tight ecosystem integration that could appeal to both productivity users and entertainment enthusiasts. If the price point holds, Samsung will be signaling that this is not a mainstream gaming device, but a premium hardware showcase meant to capture professional and enterprise interest. With South Korea chosen as the first release market, analysts see it as both a patriotic launch and a testbed before global rollout. For Samsung, Project Moohan represents a bold bet on whether XR can become a critical platform for the next decade of computing. Tech market volatility. Nvidia versus Alphabet.
On September 2, global tech stocks faced renewed downward pressure, reflecting both inflation jitters and competitive headwinds. Nvidia, which had been riding years of historic growth on AI demand, saw another sharp drop as investors weighed increasing competition from AMD and specialized AI chip startups. These concerns, combined with questions about long-term GPU demand saturation, rattled the broader semiconductor sector. Alphabet, on the other hand, bucked the downtrend after securing a favorable court ruling related to search engine payments. The decision alleviates regulatory risks and reinforces Alphabet's dominant position in the online advertising ecosystem. The contrasting performances of Nvidia and Alphabet underscored how quickly market sentiment can swing depending on legal and competitive developments, even within the same week.
Microsoft's MatterGen AI materials tool.
Microsoft researchers unveiled MatterGen, an AI system designed to accelerate the discovery of new materials. Built to function at Intel-level precision, the model can analyze potential chemical compounds and predict physical properties far faster than traditional lab methods. The tool leverages generative AI to propose novel combinations, potentially transforming industries such as semiconductors, batteries, and advanced construction materials. By digitizing the search process, MatterGen could help cut years off the timeline for new discoveries, opening pathways for breakthroughs in everything from green energy storage to lighter aerospace components. While still early in its deployment, its potential impact is being compared to how AlphaFold revolutionized protein structure research, a powerful example of AI reshaping science itself.
2D mechanically interlocked materials.
A research team recently announced the development of 2D mechanically interlocked materials that display both exceptional strength and flexibility. Unlike conventional sheet-like 2D materials such as graphene, this structure uses molecular interlocks to enhance resilience, allowing the material to bend and stretch without losing stability. These properties could lead to applications in next-generation flexible electronics, ultra-thin protective coatings, and medical implants that need durability without brittleness. The innovation highlights how materials science is pushing beyond traditional graphene-like systems into entirely new engineered architectures, designed with AI-guided and nanoscale assembly methods.
Nano-architected materials and clean power innovations.
Scientists continue to push forward with nano-architected materials, structures designed at the nanoscale to maximize strength-to-weight ratios and other mechanical properties. Recent experiments have produced ultralight but durable materials that outperform metals and polymers in extreme conditions. These advances show promise for aerospace, defense, and sustainable infrastructure. Alongside structural breakthroughs, clean power technology is benefiting from novel material architectures. Innovations include nanoscale catalysts for more efficient hydrogen production, new membranes for advanced batteries, and coatings that reduce energy loss in solar panels. These incremental but powerful shifts could play a vital role in decarbonization.
NASA IMAP probe launch.
NASA is preparing to launch its Interstellar Mapping and Acceleration Probe, IMAP, in September. Positioned at Lagrange Point 1, the mission will study the boundary between our solar system and interstellar space, measuring how solar wind interacts with cosmic particles. The data could help scientists better predict space weather, which affects satellites, astronauts, and even power grids on Earth. Beyond its scientific goals, IMAP represents a continuation of NASA's strategy to deploy cost-effective, focused missions that expand humanity's understanding of its cosmic neighborhood. By observing solar and galactic particles in real time, IMAP will build on the legacies of Voyager and IBEX, giving us the most detailed view yet of how the Sun shields Earth from interstellar radiation.
Rubin Observatory operations begin.
The Rubin Observatory in Chile is expected to commence science operations later this year, marking a new era in astronomy. Equipped with the world's largest digital camera, Rubin will generate a decade-long survey of the southern sky, capturing about 20 terabytes of data nightly. This dataset will help track near-Earth asteroids, map dark matter distribution, and study cosmic evolution. For astronomers, Rubin represents a paradigm shift from small targeted studies to continuous wide-angle monitoring of the universe. The observatory's Legacy Survey of Space and Time (LSST) is expected to yield countless discoveries, from transient supernovae to clues about dark energy. It could transform both professional astronomy and citizen science, as open data streams will allow global collaboration.
U.S. tightens controls on TSMC shipments to China.
The US government has revoked TSMC's deemed export status for its Nanjing plant, requiring strict licensing for any advanced chip-making shipments to China. This marks a major escalation in the ongoing tech trade war, tightening restrictions beyond previous export bans on AI chips. The move immediately affected the stock prices of semiconductor equipment suppliers. Strategically, Washington is aiming to slow Beijing's progress towards self-sufficient semiconductor capability. Analysts warn, however, that the decision could backfire by accelerating China's domestic chip industry and deepening global supply chain fragmentation. For companies reliant on both US and Chinese markets, the ruling introduces even more uncertainty.
China's Grand Military Parade. Laser weaponry.
During a Victory Day parade in Beijing, China showcased what it claimed to be the world's most powerful laser air defense system, alongside hypersonic missiles, drones, stealth aircraft, and advanced tanks. The event, attended by Xi Jinping, Vladimir Putin, and Kim Jong-un, was carefully orchestrated to demonstrate China's expanding military tech dominance. The laser demonstration in particular highlights Beijing's push into next-generation directed energy weapons, which could threaten traditional missile and aircraft systems. While experts debate the operational readiness of such weapons, their public display signals that China wants to be seen as a leader not just in economic and industrial tech, but in military innovation as well.
Record EV sales at Chinese brands.
Chinese EV makers posted record monthly sales in August, underlining the sector's rapid growth. XPeng delivered nearly 38,000 units, up 169% year-on-year, while NIO sold more than 31,000. Xiaomi, a relative newcomer, surpassed 30,000 deliveries with its SU7 and YU7 models. BYD maintained stability at home while boosting exports abroad. Tesla, by contrast, delivered just over 83,000 units in China, representing a 4% decline from last year. The numbers underscore how Chinese brands are not just catching up but overtaking foreign competition in their home market. With government backing, aggressive pricing, and strong consumer adoption, China's EV makers are setting the pace for the global industry.
U.S.-China AI strategies, diverging paths.
The United States and China are pursuing distinctly different strategies in the AI race. US firms like OpenAI and Google focus on long-term breakthroughs toward artificial general intelligence, investing in multimodal reasoning systems with massive compute budgets. Their vision is transformative but comes with high risk and high cost. China, meanwhile, is prioritizing practical, near-term applications, AI that improves productivity, reduces costs, and supports industrial growth. This includes chatbots for commerce, AI-powered logistics, and enterprise automation. The contrast illustrates two philosophies: America betting on revolutionary change, and China on evolutionary advantage. Both approaches will shape how AI impacts society globally.
International Humanoid Olympiad in Greece.
At ancient Olympia, humanoid robots from multiple nations competed in an Olympiad that blended sport and technology. Robots played soccer, shot arrows, and even engaged in shadowboxing, showcasing the rapid progress in robotics design and coordination. A standout demonstration featured a bionic hand translating human movements into robotic actions, hinting at breakthroughs in prosthetics and human-robot interaction. Yet experts caution that humanoid robotics is still a long way from consumer ubiquity. Challenges include limited training data, energy inefficiency, and hardware durability. For now, the event served as both a showcase of promise and a reminder of how difficult it is to scale humanoids beyond research labs and into everyday society.
New Mexico's $315 million investment.
The state of New Mexico is committing $315 million to quantum computing infrastructure, aiming to establish itself as a national hub. The plan includes funding for fabrication facilities, networking infrastructure, and grants to attract startups and researchers. Some facilities are expected to be operational as early as next year. This initiative reflects both state ambition and federal momentum to counter international competition in quantum. By supporting early ecosystems, New Mexico hopes to mirror the role Silicon Valley played for classical computing, creating clusters where research and industry reinforce one another.
Phasecraft's $34 million raise.
UK-based Phasecraft secured $34 million in fresh funding to advance its quantum algorithms for sectors like pharmaceuticals and clean energy. The company's focus is not on building hardware, but on making quantum processors useful sooner by bridging today's limited machines with practical applications. Investors are betting that Phasecraft software can deliver an early quantum advantage, where quantum systems outperform classical computers on meaningful tasks. If successful, it could accelerate real-world adoption and prove that value can be extracted even before fault-tolerant, large-scale quantum machines arrive.
IBM's India Quantum Center.
IBM has announced plans, alongside Tata Consultancy Services, to open a quantum computing center in Amaravati, Andhra Pradesh by March 2026. The facility will host a 156-qubit Heron processor and serve as part of a broader Quantum Computing Valley initiative. This marks a significant step in India's growing role in frontier technology. By situating advanced infrastructure in India, IBM and TCS are betting on a future workforce and market that will be central to the global quantum race. It also demonstrates the increasing globalization of quantum technology beyond the US, Europe, and China.
Adobe plus Gemini 2.5 integration.
Adobe announced on August 26 that it is integrating Google's Gemini 2.5 Flash image model into Firefly and Express. This allows creators to generate images with AI and then seamlessly resize, caption, and animate them inside Adobe's Creative Suite. Importantly, Adobe reassured users that their generated content would not be used to train future AI systems, addressing a common privacy concern. The move positions Adobe as both a consumer and competitor in the generative AI market. By embedding Gemini's capabilities, Adobe accelerates access to cutting-edge models while still pushing its proprietary Firefly ecosystem. It's also a sign of how quickly major creative platforms are racing to add AI layers for design efficiency.
Apple plus Gemini talks for Siri.
On August 26, Apple was reported to be in early talks with Google about licensing Gemini to enhance Siri. This potential deal would mark a major shift, as Apple has traditionally relied on its own in-house AI research for Siri development. Sources stress that no decision has been finalized, with Apple weighing whether to fully outsource or maintain hybrid control. For Apple, the stakes are high. Siri has long lagged behind competitors like Alexa and Google Assistant, and the rise of AI assistants like ChatGPT has raised the bar further. Partnering with Google could offer a quick leap forward, but it risks ceding part of the AI spotlight to a rival.
Microsoft Vibe Voice, Next Level TTS.
Microsoft Research recently open-sourced Vibe Voice, a next-generation text-to-speech model capable of producing smooth, expressive speech for up to 90 minutes continuously. The model captures nuanced tone, rhythm, and emotion, making it suitable for long-form content like podcasts, audiobooks, or lectures. Unlike traditional TTS systems, Vibe Voice emphasizes delivery quality as much as accuracy, reflecting growing demand for lifelike synthetic voices. By making the technology open and extensible, Microsoft is encouraging developers to build new applications, from accessibility tools to entertainment, on top of its framework. Vibe Voice was used to speak these stories today.